Okay. So this week's lab, again, we're exploring logic with using if statements. From here, we're looking at keyboard and mouse input controls. From this information, we'll create controller scripts that will move objects. So, basically, we're going to continue. Continue with the project you created with lab. The project you have. Continue working with it. New folder. Create a new scene sandbox. You can call it sandbox 2. You can call it lab 3. You can duplicate the current sandbox and remove what you need in the new copy, and then you will use the pair primitive prefab from Common Assets. So I'll go over that when I go over the lab itself. I'll show you what we're talking about here. We're going to talk about we're going to look at the keyboard and mouse input. We will look at gamepad later on, so don't worry about gamepad. We're going to use the new input system. We're going to go over that in class this week. I will show you the old input system, and I'll show you don't use it because it's old, it's garbage, it is broken. There's the input class, key down, don't use that. That's broken. We're going to move basically a object around. We're going to call it a grid called grid movement, and we'll put that on our object and we'll move them around. And then we'll have a capsule that will bob up and down. We will determine how high it goes, and how fast it goes, how high it goes, and it'll go up and it'll come back down. We have a worksheet for the bobbing capsule. We'll go over that as well. Let me see. I should have an image for this. Excuse me. Excuse me, I'm sneezing. Excuse me, my apologies. Okay. So let's go over so this is our lab. This is what we're doing this week. Let's go over our logic. All right, so what is an if statement? What's going on? All right, conditional statements or Boolean statements are basically Boolean math. They're statements in code that when processed will reduce down to a single true or false. X is greater than 3. Whatever X is, we can calculate that be true or false. X is equal to 5. If X is 5, that's true. If it's not equal to 5, it's false. So that's what we're talking, conditional statements. These consist of any combination of the following. Checks made using equality operations. So this is the greater than, less than, equal to, not equal to. Combination of checks with logical operations. And then just pure Boolean themselves. Which means we can use a Boolean variable as what we're checking against in like an if statement, or later on you'll use while loops. So they can exist in any combination of the following. You could use 1, you could use 2, you could use multiple things. The equality operator. Double equal signs, equal to. That's 2 equal signs. If you use 1, you are assigning a value. Greater than, less than. So these are, basically the best way to think of the value as a mouth, and the bigger side is going to eat the bigger value. So it sounds silly, but it helps. Greater than equal to. So that includes, when greater than and less than, let's say X is equal to 3. When X is 3, it is not greater than the other value. So that's when we come in greater than or equal to, less than or equal to. In those cases, when X is equal to 3, they will X is less than or equal to 3. That is true. Then we have a not equals to. So it's an exclamation point and the equal sign. So I want to check that this is not this value. And that has a lot of usage. So don't that's you'll see a lot of uses of this value. In fact, you'll see this week with input. So we'll be using it right away. All right, logical operators. So it's the double ampersand, double pipes. This is what we call. This is the key next to, so above the enter key, there is the curly braces, the hard braces, and then there's one of the slashes. Shift that slash gives you the pipe. And then a single equal, the application point will be the not operator. So we can use that on like a Boolean. All right. Can we put Unreal away, please? Yeah, this is a class on Unity, not Unreal. So please put that away. Yeah, close the window, please. All right. So we're talking about if statements here. So basically, this is your first logical structure. Think of it as a pattern. The first way we look at it is that we have an if statement in parentheses. We then have a conditional statement. So a Boolean, x is equal to 2, and other checks. Then we have a code block, and inside that, if that is true, we will do the code that is inside that block. This is our first way we go. The next, there are some alternative styles where basically you use a single line of code, and you don't use the code block. That means that after the if statement, the next line of code is what will run, and only that one line. The moment you add another line of code you need to add in there, you now have to put the braces back in. So always, use the braces. There's a version where you put the brace on the with the if statement. It's a stylistic choice, but it's not a great stylistic choice. So we'll move on. The next structure is the if-else structure. So we have an if statement and an else structure. So again, like as before, if this is true, the code in here will run. Else, if the conditional statement is false, it will come false down in here. And this is common in C, C++, C#, Java, to a certain extent JavaScript. So there is another structure. It is less used, and I will actually advise you not to use this if you can. So you have a first conditional statement, then an if-else, and then it checks a second conditional statement. So if the first one is, if it's true, it does that first block. If that's not false, it goes to the second if-else, which is the second conditional statement, and it does that block if it's true, and if it's still false, it does that third block if the second is false. So this can get complicated and convoluted, and it's harder to read than using. There's better ways we could handle this. Using multiple if statements is one way, actually, just pure if statements. If this is true, we do this. If this is true, we do the next block.
So like a nested if statement?
This is we're starting to nest things here. Okay. So what you're asking about nested, so we have an if statement inside an if statement. That's what we call by nesting. There are times when that is okay, and there are times when that gets convoluted. So I'm showing you this so you know that it's there. If you're using if, else, you're probably barking up the wrong tree. You probably should come talk to me about how I should structure the logic going there. I'm perfectly fine with multiple just if statements. Just if this is true, do that. If this is true, do that. If this is true, do that. If this is the scenario I'm looking at, do that. And we'll actually use this style of if statements actually with some of the code that we'll write. Later on, you'll see this, particularly with the gamepad. When we start using gamepads, one of the things we'll do is we will match things. We will get our input from the keyboard and mouse and assign it to a structure that basically simulates a gamepad later on. We'll talk about that later on. So, but you will see that structure very quickly. All right, let's go over input. All right, when we think about inputs, we're thinking about keyboards, we're thinking about mouse, we're thinking about controllers, joystick. So the term joystick is, and the way that we need to think about it is that if it's not a keyboard, if it's not a mouse and a controller, it's defined, then Microsoft says it's some sort of joystick. And that's the way that you need to think about joysticks in terms of input in this level. When we talk about actual controllers, I got a controller out right now. When we look at we would traditionally call joysticks as well. They are referred to as thumbsticks in terms of, so they're not, again, while these look like the term joystick that I'm trying to get across to, when you're talking about in a software engineering standpoint, it's pretty much anything that it's a catch-all for any other device that doesn't follow being a keyboard or a mouse or controller or these other inputs that have been defined. So a lot of, and don't get me wrong, a lot of joysticks fall under this category, but these also, if you are into fight simulation and fight gear, like there's panels and there's gears, like for how much you control the power of your engines. That's considered that device comes in as a joystick. So we are only going to pretty much talk about mouse and keyboard today. We will talk about controllers later on. Touchscreens, that's a whole class just for that. That's mobile. That's mobile stuff. Camera, mobile again comes into the camera and extended reality. Voice, you might play with voice. Motion that would become off camera as well. So there's other types of inputs. All right, we need to know there's two input systems. I've talked about it. The legacy input, basic keyboard and mouse is very easy. Hard-coded to input system, bound axes and buttons, doesn't support multiplayer controllers well at all. In fact, different brands have different binds. So how you bind the Xbox controller versus the Xbox gamepad versus the PlayStation gamepad, totally different under that old legacy system. And there are things wrong with the legacy system. It's so bad that two things. Unity historically, when it was just the input system, it was so bad. People were making money selling alternative input systems, so you could do things like bind and handle things better. And I can tell you that Sony wrote their own API for input because that system was so horrible. I'm not sure if I should be sharing that, but I don't care. I don't think Sony really cares. I don't think Sony would really care that much. It's just history at this point. Well, when we talk about the input manager, it's a package that is now added to it has been enabled when you make your project. Now, that's actually not true anymore. I have to take that out. That is now in part of the project you make is now enabled. Supports multiple gamepads. Streamlined support with multiple controller types. I've gotten 22 controllers recognized on one PC at one point. I had mine, and I had this is what my previous job. I had a set of 10 PlayStation controllers and a set of 10. No, I'm trying to remember. I want to say I had a set of 10 PlayStation controllers and 10 set of Xbox controllers. I had multiple some controllers that I had as well. And the only reason we only got to 22 because we didn't have more controllers and we didn't have another USB hub to connect them to. I had two 10-port USB hubs when I connected controllers to. So, it was more of we could do more, we just didn't have the hardware to do more. There's a new system to create controller profiles. That's basically a binding, is a system. I'll point that out to you. And I'll point out there's two things that you can do with that particular system. But our focus will be working with devices. And that's what the new input system is designed around. It's around devices. So just so you can see the legacy system, input dot any key down, get key down, get key up. There's a key code class. Hooray, that basically all the keys are in there. This is part of the legacy system. Again, you're not going to use it. But if you see key code, something, get key down, get key up, that's the input system. Don't use it. It doesn't work. It doesn't work very well. And I will know that if you're using this, you're not paying attention. You have not paid attention. You're copying code in mass. Or you're using AI to write your code. Because they'll use this old input system and not be like, oh, I don't know. I'm an AI. I don't know better. I'm just going to scrape code off of Stack Overflow. Do you know how many people are wrong on Stack Overflow? We're not talking like 50%. We're not even talking like 20%. 20% right. We're like in the 10% percentile, maybe, to Stack Overflow. So don't use these input systems, is basically what I'm saying. Key code class, this is the mouse, input get mouse button, input get mouse position, scroll delta. Yeah, don't use these. There'll be other ways, there'll be a better way to deal with that. And the button numbers is basically 0, 1, and 2. All right, the input system. The input system is its own package. In order to use it in a script, you need to add the following line to the using section. So it's using UniEngine.input system. And we'll go over that in our the first file that we will play with is the test bed. That that first, and you'll see that right away. 2. Each device has a class that defines the input, and you use .current to get the current device. So keyboard is a class in that system. Mouse is a class in that system. Gamepad. These are the 3 classes you will be using mostly right now. And then you'll get those devices .current, mouse.current, gamepad.current. The problem is the first thing you have to do is to validate that whatever you get here is valid. You get device, you assign a local variable to the device, you check if the variable is valid. And if you don't have data from the .current, it will return null. What does that look like? If keyboard is not equal to null. So when we're dealing with, again, keyboard.current gets an instance of the object of a keyboard class. And if you have that, KB in our case right here is our variable. If this is valid, then this won't be a null variable. If we're on like a phone, this is going to be a null variable because there's no keyboard. Certain extent, there's hacks, not always, but like if we could be on a device that doesn't have a mouse. Mouse is not equal to null. A good example that more practical is the gamepad. If we don't have a gamepad connected to the PC, gamepad.current is going to give back a null variable. All right, need to jump in quickly. We need to talk about null versus what is a null. When we're dealing with structures and we're dealing with classes, particularly with classes, the value of a class can hold a particular value, the structure of something, or it can sometimes not hold anything at all. So let's back up. We're not talking like with an integer, like 0 is nothing, but that's a value. That's still a value. Let me bring up. There's a wonderful image. Null versus 0. You will understand this really easily. All right. In the case of 0, The toilet paper roll is our variable. It has no toilet paper on it. That is 0. In the case of null, we don't even have a variable. We don't have an object instance. It's null. It's kind of funny. The third one here is undefined. So in this case, we haven't even defined a variable. We don't even have a toilet paper roll we don't even have a variable for it to hold the toilet paper. So we haven't even created the variable. So this is we have KB, keyboard is equal to KB. That this toilet paper roll is the variable that we're talking about. In this case, we have not defined it. KB is equal to null. It means we asked keyboard.current and we got a null variable back. We don't have a keyboard, so we don't have any information to deal with. And then finally, we have our values with, if we got an actual value, then we would get a value. Again, 0, again, in case the toilet paper roll is the instance of our toilet paper. If the roll has nothing on it, it's a 0. If we don't have a toilet paper roll, we don't even have an instance of toilet paper. And undefined, this is bad to worse to, oh my God, what is going on? So, needed this quick aside, and I'll make sure this is uploaded to Canvas. But here's how we validate. Again, keyboard.current. Keyboard is the type of what we're dealing with. KB is our variable. Again, right now I am declaring the variable and initializing it right away. And then the next line is I'm checking against it. And then everything in between these here, between here and here, then KB is valid. I can write my keyboard code what I want to do here. There is a tactic that we're going to use. Basically, one of the things you will do is you will create variables that you will assign. And I'll show that to you. Basically, rather than writing our code like remove the character, no, we will write this specifically first and assign values that we will look at. And this again helps us. This will keep our code separated in functionality. Asking for our input is an action that we must do. Responding to our actions is a operation that we must do. But they're two separate operations. We'll separate them out. We use IntelliSense to find the property of the device you want to read. So spacebar on keyboard is represented by space key. Axes. So input values return back a float, a vector, vector 3, use read value. So axes, think like the joystick, the thumbstick. You push forward on the thumbstick, you get back 2 floats. It's a vector 2. The triggers, you pull down on them, you get a float. That's an axis. Your controller, your VR controllers, the position in space relative to you, that's a vector 3. So when you're dealing with something that's a float, a vector 2, a vector 3, you will use read value to get the value. So again, here is gamepad, left trigger, read value, D-pad, read value. And these are, again, vector 2, left stick, read value. So read value will correspond to the correct, you'll get the correct value back from read value based on the type that you're looking for. So in this case, left trigger is a float. By underneath the scenes, it's a float, so we use read value on it to get the value that we want. Buttons are just what they are. They return Boolean values. There are 3 properties that you will use to determine. So it is basically north button, was pressed this frame, south button, was released this frame, and then this is button is pressed, and then if we put an exclamation part, we can say is not pressed. You can see that this is Unity has, so this is how we get back the Boolean. So was pressed this frame, so I pressed the button this frame. Was released. I've gone from being pressed down and I've just released the button. So a good example, Mega Man 3, basically you can hold down the button So that's the is pressed. It sees how long you've held the button down, and as that gets bigger, Mega Man starts blinking bigger and brighter because you're going to shoot a bigger bullet. You tap it pretty quickly. You shoot the little bullet. Hold it down. You get the second bigger bullet, and you hold it down like another 2 seconds. You get the biggest shot that you can make with the Mega Buster. So again, this is an example of when it was pressed that frame, it starts recording how long you've pressed it. When you release it, it checks, is pressed. It says, well, I'm still holding it down, adds to a counter. And then finally was released this frame basically is when you're actually going to shoot in Mega Man 3. Because and the shot is based on how long you held it down. Let's get this to the top. Here we go. My apologies. Button north, button south, button east, button west. What are we talking about here? Well, what's the top button on a place? So on the Xbox, the north button is Y. I think I have to look up what the Yeah. So let me grab the PlayStation controller. For the PlayStation, that top button is triangle. So what Unity has done is basically taken those 4 buttons, and they've abstracted them to north, south, east, west, because how Sony does it and how Microsoft does it is different, and how the Switch and Nintendo has done it has differed as well. There's no standard. One might be X, one might be Y, one might be A. This is triangle. Yay, Sony. So let's back up. So the idea is that we've taken those 4 buttons and we've abstracted them as north, south, east, west, so that you can refer to them consistently across platforms. There'll be others that will, left stick, right stick. Those are different things you'll be able to access. You have to be careful with how you. Yeah, I haven't used Unity on the Switch or the Switch 2, so there's development kits for that platform. I don't know if you were to get a Switch development or a Switch 2 development kit, you could then play around and see how the different side controllers work, how they work, and how they work independently of each other as well. So that's how, so by using only 2 controllers, they can get 4 players on the same game. And that's basically, and that's, we're thinking with that, where we've got, the four basic buttons, the stick, and maybe 1 or 2 other buttons that are available in a trigger. So. All right. Let's jump into Unity now. Yes, go. You don't need to ask me. You just go. All right, here we go. All right, so let's jump back to our lab. And so the first thing we're going to do right now is the keyboard and mouse test. And I'm just going to open this up quickly. That's nice. Yeah, I'm going to show you the device test. So this is code that was given to you. It's given to you. And so basically what we're doing right now in updates, so you can see there's a lot of code here. One of the first things we'll actually do is we'll jump, let me close this, I don't need that open. We'll jump all this into essentially its own function to separate it out. So, this is why we write functions. And I'll show you technically I'll show you the basic functionality for a function this week. I'll close you. Here we go. Let's jump into Unity. And let's go to, make a new folder, Lab 03. And I'm actually just going to start with a new scene. I'll start with a basic. And then I will go to my common assets. Here's the prototype prefabs. So here's the gray floor. Make sure that's 0, 0, 0. And then I'm going to drop this user prefab. So this is the user prefab permit. This is what I talked about. We'll need one of these in the scene. I'll go over how that's structured in a moment. But I'm just going to, for the sake of argument, you know, I'm just going to use, let's go back to, there you go. So we put a material on there and make it look nicer. All right. We'll come back and we'll be using for the grid movement. All right. So let's start with our input. So I'm actually going to go to the floor itself. Let me see. I'm actually going to, let's file, save as, lab 3. So I'm going to save it as lab 03. And I'm going to go in here, I'm going to create a new model behavior script. And this is going to be, I'm going to do this one more time. And I need to, okay, input, test. All right, so let me get rid of this script right here. So don't leave this new model behavior script. Don't get rid of these. Don't use that as your name. And I'm going to just put this on the gray floor for the sake of argument, just so I have a place. Now I can turn this off by clicking this button right here. So this would turn off the script effectively. That's because we have an input and we have a we have a start and we have an update function in that script. That's why if we don't have either of those, then that checkbox won't be available to you. We will eventually turn this off. So there are two other scripts. I'm going to make them right now so they're out of the way. So that'll be the grid movement. And I'm going to create one more. I'm going to call it the bobber script. Just so we have an idea, I will be attaching the grid movement to the user prefab. So I'm just going to call this player 1. And then ultimately later on we will need another 3D object. And I'm going to use I'll use a cylinder. And that looks big of 1, 0. Okay. So this will be my bobber. And we'll talk about how this is going to get structured in a moment. This may not how I'll actually use the bobber. So we'll see. Things to look at. So up here right now, I've got it set to pivot. It will start at center. Make sure you go to pivot. And that's because basically you want to work where the object is oriented and not the center of the object. That makes more sense, ultimately. I'm going to go back to global in this case. So basically this is coordinates. So when I rotate something, so let's just take them and let's rotate them just a little bit. And I go back to, you can see that they're under local, that these axes are aligned with how it's rotated. Global keeps it on the global axis. So right now, for our purposes right now, we're going to stay with the global axis. I'll put that back to 0. So we're going to next week we'll actually dig into rotations. So we're not going to play with rotations this week. We'll play with them next week. So, all right, we'll bring up input test. And I can close all of these windows. There we go. Lab 3, input test. I'll bring up all these as well, but. All right, input test. So let's take a look at the code that I showed you. Basically, it is void update and all this code. Now, I'm not going to copy all this code right away. What I'm going to do is I'm going to write a new function. So it's going to be void check input. And and I can then call that by calling check input semicolon. Now, right now, this is a void function. Doesn't return anything. It's just a single serving jack is basically the best way to describe this. It does its thing, doesn't take anything, doesn't return anything. Parentheses right here. Basically, this is again you write a void. Basically, right now for our purposes, we're writing void functions. Name of the function, parentheses, and then we open up a code block. And what's in that code block is what gets called when the function is called. How do we call the function? It's the name of the function, parentheses, semicolon. Now, again, this function is not taking any parameters, so don't worry. Again, don't worry about that. I mean, what I mean basically is like we can do int check input int number. So return. Sorry, we want to do. I'll call this add 1. So essentially, we're giving an integer. It takes that integer, adds 1 to it, returns it. We'll talk more about functions later on next week, but I do definitely want you to use this pattern right here because it'll clean up your code very cleanly. It makes your code cleaner. So again, all that code that I have here in the update, I will now grab and I'll put it in check input instead. So I've got something for my keyboard, I've got something for my mouse, I've got something if I have a gamepad. We're gonna set up we'll set up 3 booleans. Well, bool, spacebar. And so when you're creating variables that represent input, always assign them to be false or to be 0 or to not to have a value like a neutral, a non-value. So like if you're not pressing the keyboard, then that should be then that should end up being if you're not pressing the keyboard or you're not pressing the trigger, then that trigger value should be 0. We'll do a bool left mouse button is equal to false. We'll start with that. We'll do another bool tab key is equal to false. So this is input variables. So we'll start with these basic buttons. So we'll go down to keyboard. Now that we know that keyboard is valid, we can actually say, hey, space. So the variable that we've created is spacebar, and we can go to, hey, keyboard dot space key. If we want to look at the backspace, it would be backspace key. Let's take a look at others. A key, W key. So like all the letters are of the letter key. Let's go back to space key in this case. And again, we can just ask, was press this frame. Let me see, the tab key. Again, tab key, was released this frame. So when you want to get IntelliSense back, you've messed it up that way, just delete the dot, hit the dot again, and it'll bring it up. So here is was released this frame. And again, I got the semicolon by hitting the tab key. That's the autocorrect. I mean, the correction, the code suggestion. So I've got a way to look at, hey, the spacebar was pressed. I can know when the tab key was released. Do one more. Pull left. So I'll do the left shift, and then we'll do left shift is equal to KB. Left shift key is pressed. So we've got our three. Yeah. So basically, our keyboard's pretty straightforward. The idea is that you want to hold variables for that. Pull your information into to a place where you can pull all that information, and then operate on it. So again, example here, we can go in if, again, these are if spacebar, debug.log, bar was pressed. Tab key. Where's the yellow about it? Oh, it's capital L. There we go. I am just going to go in and I'm going to put in an integer. Int. And just for argument, just to initialize always initialize properly, I'm going to drop it into start. So start is a place where you would initialize things. One of two places where you initialize things. So left shift counter, we're going to set that to 0. In the case of left shift, that's the. I'm going to add one. Oh, let me not undo that. So this is a case where I'm going to add to my counter. And we'll go in and we'll say, hey, and we'll add the left shift counter. So I'll put a number out to my log, and we'll see that we'll see numbers go up. Now, there is a case of right now we're going to keep this as its own code here. And in fact, I should actually good practice is to put an empty space after a block of code. So that made that a lot more readable. Let's just jump down into mouse, and we'll grab left. Mouse button is equal to mouse. Left button was press this frame. And we can go in, basically, I will grab the space bar and I'll put this in. So I've got my left mouse button. Other things that we can do with the mouse. So I know mouse. So we know a vector 2 will be our So our mouse location is going to be a vector 2. So we'll just jump down. Hey, we'll grab the mouse location as our variable. We'll just go in. Mouse location is going to be equal to mouse dot position, and this is going to be a read value. And we can go in. Let's see. Let's do this when the tab key is. So one of the things I'll do right now, tab key is released, and on here, just for the sake of argument for us to do it, debug. Location. We'll use what's called toString. So we're converting it from a vector3 to basically. We can do it without it. It will convert it normally, because C# will do that for you. But ideally, you should be using the toString method. So when I hit the tab key, wherever a mouse is, will show up on screen. And the only reason I'm doing it this way is so that I'm not spamming my console log with the mouse position. It's the only reason why I'm doing it in this way. So we'll save this. So here's my mouse test. Jump back to Unity. We'll go to the console log. Clear these out. It's not important. So make sure you click inside the game window in order to get your input. So here is, you see, again, I'll uncollapse it. Here is spacebar. So for our screen purposes, this is going to get interesting. You looked at that. I'm as close as I can get to the corner. It's four pixels over, 6 pixels over. So down here is the origin of the screen. That's interesting because that's Cartesian coordinates. You will see in most cases, the origin of the screen is up here. So Unity has made a very specific choice to flip that. So just so you know that going up Y, going up is going to go you up on 2 dimensions on the screen. That's not always the case. Going positive on the Y value in most scenarios means you're going down the screen. So just be mindful of that. Those of you who are working in Unreal, that up here is going to be your 0, 0. Now you can move the orientation, and there's ways to move the orientation around, but for our purposes right now, just be mindful that Unity's got it down in this corner right here. And that's, we're looking at what we're doing. Again, I'm moving my mouse and I'm hitting tab to get my different values. So far, so good with what we're doing. All right. Again, this is just basically, can you write the code that can you do the basic inputs? Again, the big thing here, again, what I'm just trying to show you is that, hey, we're gonna just do we're gonna pull our input into one function. You don't have to this week. I don't think I have you, but I mean, basically what's going on is all this code here is being dropped in right here in this place. Later on, you will see different scenarios, if statements, and we'll actually just call functions with information. Like later on, there'll be movement, move forward, move, rotate. Those functions we will actually write, and we'll just hand it a value. So. All right, let's talk about our grid movement. All right, so the first, there's a couple of values that we need to come up with first. Is a float grid size, and I'm going to set that to 2. I'll set that to 3 right now. this is how far is our character going to move. So with the grid movement, we are moving on. So when we press the button down, we move forward. We move. Only when we press the button down. So on pressed. We'll deal with is pressed next week with that smooth movement. Literally, we will take the code here and we'll move it to the smooth movement later on. That's next week. So right now we're just jumping around like we're on a grid. Our grid is 3 units big. This will help us control how far we move. And we do want to make this public so we can control that in the editor. What we don't want to control in the editor is our input variables. And this is going to be, there'll be 4 of them, and this will be, they're all bools, north, and I'm going to add the word movement onto them. So we're not just a single word right here. And this will make, and later on this will be forward, back, left, right. So I am going to go into update, and I am going to make, so let's do the void check input. And let's put that right away into our update, so we don't, because if we forget to do this, we're not checking input, and then we're not doing anything. And we're like, we look at, it's running, but the code compiled. What are we doing wrong? So this is if your code's not first saying check, are you actually calling the check input function? And this will be required next week with smooth movement. So just to be mindful of that. Check input, basically, again, this is a keyboard. And we need to go into using, did I not add it in the input test? No, I did. Okay. I don't know why we have visual scripting here, but we don't need it. But we do need the input, using Unity Engine.input system. There we go. So now keyboard KB is equal to keyboard.current. Give me one moment. And then we're just going to check if KB is not equal to null. We'll do what we need inside here. North movement. What are you doing? Equal to KB W key was pressed this frame. So all of our keys are going to be in that style. Oh, I am. So. There we go. So this will be south, east, west, and just, if I can spell west correctly, one thing that you might want to do is put a space in here to count for, there's one less letter. So these all line up. This is something that you can do. The other way would be to go use a tab. And so in our case, the south key is going to be S. East is going to be A. And west is going to be D. So we've got basically our 4 key presses that we're looking for in play right away. Extra credit. set up a second player. You would, again, use a Boolean would be the best way to handle that. A, and B, use multiple functions. It's the cleanest way to do that. Just handing that out there as possible extra credit to doing this assignment. You will. Don't use WSAD this week because we will use that next week. Use so this would be J, K, and L. Yeah, use those keys this week because we'll use WSAD next week. So to bite that bullet, use the IJKL this week. If you want to do that in that particular order, we can. So here we go. So we've got our inputs right here. We don't have anything that we need to worry about in terms of start. And it's basically when we press down on one of these buttons, we're going to move our character. And literally what I'm going to make a variable here, vector 3, I'll assign it to vector 3, 0. So if I don't have any input, basically I'm going, if I don't have any input, then I'm going to do a vector 3, my movement distance is going to be vector 3, 0. Let's before we get into that, let's do the movement code. So that's, and I'm doing this in a particular way to make it like operation. So let's do the last thing we were going to do is move it. So we will do a vector 3 position is equal to our game object dot transform dot position. Our position will add to our move distance, and I will get this correct with the lowercase m. And then again, game object dot transform position. So we're flipping it back around. Lab, the move script from lab 2. Hooray. The only thing that we're doing different is that we're setting this move distance variable. And I'm doing it this way so that we create the variable, we assign it, we to figure out what that is, and then we use it. And again, we're using it in patterns that you've seen. In fact, I would actually, by definition, I would put this up here. And then we can do if north movement, move distance is going to be plus equals to vector 3 dot forward. And we're going to multiply it by the grid size. Again, I can go and I can. And this will be south. Vector 3 dot back. So again, we will look at. Let me make sure I get this correct. So forward is 1 on the z-axis. Back is going to be -1 on that z-axis. Again, we're multiplying by grid size to get what we want. Again, we'll do east. This will be left. And then move, the last one is going to be west. Right. So left will be -1 on the global axis. And then right will be +1 on the global axis. If we've pressed 2 keys at the same time, we will move in a diagonal. Won't always be that way because you might press one and then the other on the next tick by. So it's not always going to happen. One thing that we can do So now that we've done this, the last thing that we can do is we can actually set the forward direction of our object. And that's going to be our game object.transform.forward. We're going to use the move distance. Right now our move distance has direction and how far it is. By giving this variable, it will basically strip out the distance and just give it the direction that we want. Hint, this will be a nicety for our code. The only thing that we want to do is basically, it will yell about this, and we will just basically say, hey, if move distance dot magnitude is greater than 0. We will talk about this next week. So if we have our move distance right here and we don't press a button, then it's basically going to give us a 0, 0 across the board. And the magnitude, so we won't even get a grid size times 3. It'll just be a 0 of the magnitude. How the length of that vector will be a 0. We'll talk about that next week. So I'm dipping in. So doing this right here, totally extra credit, because we're going to talk about that in detail next week. So let's jump into game, and I need to scene view. Actually, I want the game view here instead. There we go. So honestly, I want to just work in my scene view. So I'm just gonna press play. Give it a sec. So player 1 has the script here. I'll press play. I'll click in game world, and you can see let's not click on that. So you can see that I'm looking down at the camera on him or them. And off we go. We're moving around. Again, I could let's go look at the player one more time. Give a grid distance of 1. I'll do 0.75. What the heck? This will make values interesting. You can see the rotation change. Scroll out, lot, and then we'll do 10. It's not. Oh, there we go. You can see, there it goes. And we can go off the world because we don't have gravity enabled and all that good stuff. We'll worry about that another time. But right now we are moving the object based on position. Later on, in 2 weeks, we'll move it based on physics properties, with physics. And there'll be a reason why we'll do that. Mostly collisions, dealing with collisions better is what we want. But right now I'm showing off the basics with, hey, moving around. So again, the big thing that we saw is that, hey, we created input variables. We pulled them, and then did something. Got the input. We pulled them, and then again moved the object. So, we doing so far so good? If you get home and you completely forget about everything, again, A, the lecture's recorded. B, ask me questions. All right. So we're going to work with the Bobber script. Now, the Bobber script does not have input, but it does have a couple of variables that we do need to create for it. We do need to know, we'll do a vector 3, not a vector. We'll get the starting location. We're going to assign it because we'll get that on start. In fact, we'll do that right now. Starting location is equal to GameObject.transform.position, so that we have that stated. We do want a public bob height, and we'll set that to 10 for our purposes right now. And I need to set that to be a float, a public float bob speed. We'll set that to 2.5. And that needs to be an F. And I need to spell public right. There we go. So this is how far up we're going to go. And the other one is how fast we are going to go. This will make our lives easier in terms of the calculations that we need to do. And that's going to be a float ceiling, float floor. All right, we don't necessarily need to create these variables, but it will make our lives easier. Where's the ceiling? And we're only going, again, the big thing is that we are only moving on the y-axis. So the ceiling, we'll do the floor first. Floor is easy. Floor is equal to our starting location dot y. And our ceiling is going to be equal to our starting location dot y plus the bob height. So we're initializing things to use at start, and if values get changed, we're not taking that into account those changes later on. So just be mindful of that, and that's okay for this week. All right, I'm not worrying about you need to recalculate the bob height because that this variable changed. No. That's too much, too soon. So, the other thing that we need to know is which direction we are moving. And I do a Boolean is moving up. There's another way we could do this, and then it's an integer move So this is going to basically, with this, we will either have a 1 or a -1. We'll talk about which is useful. We'll talk about which one we should be using. Both are valid. We'll talk about the pros and cons of each as we get further. And that's one of the things, right away, there's more than one way to how we handle this. We can assign we have a variable. We can use a Boolean to control this, or we can use it to be a part of the calculation. So we'll do both, and I'll show you to see. So yeah, we'll do both in this case. Sake of argument, move direction is going to be equal to. We're just going to initialize that to basically be 1. So we're always starting from our starting location. We're always moving up. All right, let's start with our logic. So we know that we have a vector 3 location, and that's going to be equal to our GameObject.transform.position. And then at some point, GameObject.transform.position is going to be equal to location. First thing that we'll want to do is basically is an if statement is moving up. If that's true, then basically our location is equal is going to be plus. We're going to add to the location sorry, it's going to be location.y. It's going to be plus equals our Bob speed times time dot delta time, because we got to control that. Now, we're not using time delta time on the grid movement because we're moving based on key presses. So if I hit that 15 times in 2 seconds, I'm going to move 15 move calls. But we're moving over time, so that's why we're doing that here in this case. And then conversely, we have the else statement block here. And that's going to be basically this same line of code, but it's going to be location.y. Oh, I lost my semicolon. Minus. We can do this with the move direction variable, and that is simply this line of code. Both time direction times move direction. Save this. I'm actually going to comment this out. Yeah, I'm going to comment this out so that we're only doing this once. Either way is perfectly fine. You'll find that as we move on, this will be more that move direction is going to be the way that we'll handle things. Like you could handle moving forward and backwards with one function if you provided a 1 or a -1 or a value in between. And again, think the thumbsticks. You know, you push forward, that's a 1. You push back on it, that's a -1 on that y. You push to the right, that's 1. You push to the left, that's a -1. And you can get something in between. So I'm going to save this. I'm going to jump back to Unity. And we're just going to basically look at this. And this is going to go up. Now, it's going to keep going up because it's not, because we haven't done any checks yet. There you go. Press play. And the bobber object does not have the bobber script. There we go. And we now have a rocket. Well, it's not really a rocket. There we go. Now it's more like a rocket. But it went past 2.5. So we now, what we need to do is now check. So the first is we need to check whether we've gone above our ceiling. And that's going to be, you know, this is going to be check if above ceiling. And that's going to be our location.y is greater than or equal to our ceiling. And you know, we could have done we could have popped that in right here, but this is easier to read and easier to manage. If that's the case, is moving up, it's going to be equal to false. We're going to do the move direction as well, even though we're doing both. Move direction. So ideally, you would assign that to be -1. And grab that and paste that in. And ideally, we would want to keep the object within the scope. So the floor to ceiling is where the object should be moving. So just on a make sure that we're not we're keeping, you know, this is a, you don't necessarily have to do this, but we'll do this to keep things orderly. We'll just do location dot y is equal to the ceiling. Snap it to the ceiling. We may go past it, that's fine. we'll just snap it back to the ceiling because we want to say we're in that this object should be in this range. And this is us being asserting that's important. Now that may not be important in some cases, and you can leave that out. That's up for you to decide. But for our purposes right now, I'm going to be anal retentive and say this is important and it must be in this range. Does it? No, not necessarily. But I'm just showing it to you so that you know that you should do this and can do this. And that's basically how you define what your player, the place your object is in. It may, there'll be cases where this is really important, and there'll be cases where it's like, no big deal. We're above. We're gonna go moving back down anyways. So it's not gonna be that important. So I'm gonna save this. We're not done yet, but I'm just gonna show you that hey, that first check is working. And we'll just press play. And it goes up, and it comes down, and it keeps coming down, and it goes through the floor. So, what's up?
The ceiling function.
This right here?
How is it defined? Not the actual, the variable. Sorry.
Ceiling.
Variable.
So remember, we defined these up here. These are part of the class. We assigned them in start. So we got the start leading location. We set the floor. We set the ceiling. I set the movement direction. In theory, I probably should do is moving up is equal to true here as well. Again, you wouldn't use both. So again, you'd pick one or the other. And again, of these two, the move direction. This is 1 or -1, and this is. And over time, you'll prefer the 1 or -1. But again, we're showing the if statements off this week and a Boolean. Again, not saying that is moving up is wrong. It's just there's more flexibility with the move direction in some cases. So again, basically, it's going to be another if statement. If location dot y is less than or equal to the floor, so again, we do is moving up is equal to true. Move direction is equal to +1. And you can get away with the +1. It shouldn't complain about that. It's just ideally you won't always see that. Location dot y is equal to the floor. Snap to floor. And we can save that. And now when I run it, goes up, it comes down, it's going to hit the floor, and it bounces back up. And I can go and this is one of the options you can crank up. So I'll do 5. We can do. Let me get the bob height to like 3, and you can see this. We can crank the speed up to 5. We can crank this up to 10. $21. So, and you can play with this as you see fit. I mean, like I've done things that were subtle, like 0.2. or actually like I do like 0.5. And I could actually probably crank this up to 0.4 to get a more of a bob. So things to so it's okay as it works right now, because when it gets its starting location, let's get this to 0. Clear out that value. It is using its again. If you look at it, we're starting in the center of this object. Let me remove this. We can remove the component. Let's actually rebuild this. Let's actually build this with an empty parent. We'll call this the bobber model. And here is the object right here. Let's set this to y is equal to 0. And we'll go into the model and we'll set this up to 1. So now when we go to the object, we can actually get the bobber script here. And now we're actually starting with an orientation point down here. And that's more typical of what you would expect for your player. Again, we look at the player 1. They're set up, again, they have a capsule and a cube. Capsule's moved up 1 unit, and the cube is scaled in a weird way. It's scaled in a weird way to give you this visor looking thing. But you don't have to build this. Again, that's the reason you have that in your common assets. So again, don't need to do, again, we'll call this the bobber object. Here's the bobber model. So you'll see this structure where you have a empty root object that is basically there to recognize the object at its origin point in terms of the world, its pivot point. Again, this is why, like, hey, we can go to center, and like that makes no sense. Like it's the center of the object. That makes no sense. Yeah. So don't use center. Use pivot. Is what I'm saying. Right now we're using primarily global. Next week, local will make more sense. So literally the next piece in your lab 4 is we take the grid movement script, and we upgrade it to smooth movement instead. And you'll move forward, back and forth, and you rotate around. And there's another piece next week as well that will make your lab look like magic. So these labs again are building upon each other. Particularly these early labs, these first 2, 3, 4 set you up for 5, 6, 7, and 8. 5, 6, 7, and then 8 is your UI. 9 is packaging everything together, and 9 and 10 is about packaging up. Changing scenes and packaging up. So, will these scenes matter? Like when you get to scene lab 10? Not really. Not if you want to. There's three primary scenes you're going to build. There's little mini games, and so we're building towards them at this moment. All right. And this is pretty much your lab this week. This is, you're bobbing up and down with one object. You're moving around with the grid. Don't worry about if you're not getting the facing correct. That's okay. I've shown you how to do it correctly, and it'll make more sense next week when we go over vector. We're going to have a whole lecture on vectors, and where we go into detail what a vector is. So don't worry too much. Just follow along that the vector 3 times the move grid is what you need to do this week for your code, and you'll be fine. Don't forget to save your scene, and you should be good. Any questions for me about this week's assignment? Okay. What's up?
Could I just see how you finish off the bobber script again?
So how I finish off the bobber script? So what you're talking about these? Yeah. So again, let's comment here. If check if below the floor, and I should use the ceiling. Use English. meant to be read by someone. Don't worry, there's worse comments out there.
So is I'm assuming the move direction from location floor is just saying if it is less than or equal to the floor, it's going to move back upwards?
Yep, we're moving it back up. Yep. And again, the first is we're using the Boolean to determine where we're going up or down. The second one is if we were using that value, 1 or -1, if we were moving up or down. I'm doing both so you can see it. But I mean, like one thing that I don't want you to use this week is the math operators like sine or cosine. Not off limits this week. I understand that is a valid way to do the bobbing. It's not how I want you to do the bobbing this week. I want you to do these if statements. In theory, yeah. If you want to be a math nerd, be a math nerd later on. Not right now, please. This is if you'd like to do the bobber with sine and cosine, do another class. Like call it bobber sine movement, bobber cosine movement, and then submit that additional class for extra credit. But right now, that's getting into that's getting particular with math in a way that we're not focused on right now. Our focus is on like this is the heart of this assignment right here is in these if statements, or in this one right here because we're using the Boolean. This class is about using if statements. It's not about using how hard can you math. That's not our goal right now. And there's a whole course about how hard we can math. So, any other questions? Anything someone want to see again? Again, this will be I'll be uploading these in a little bit after this. So. And they'll be linked. I'll make sure to publish them this time. My apologies. Wish someone had told me sooner because I would have known that I didn't. You sent it today. Yeah, I wish it was not. By that time, I was, it was too late for me to do anything because I was getting ready to be here. Yeah, had someone said something like Thursday or Friday, I could have fixed it could have fixed it. Yeah. So yeah, if you don't see the lecture video, please say something. Any other questions? All right. I'm going to end the recording right here.